This problem is related to alternating series and remainders. And what we need to know here is that if we take a convergent alternating series and we estimate the sum by chopping it off at some point and just adding the first couple terms, we can figure out something about the remainder or the error. So if we estimate with the first n terms, then the magnitude of the remainder is less than or equal to the first omitted term. Down here we have a series that's a convergent alternating series, and our directions are to estimate the value of the series with an absolute error less than 10 to the negative 3. So let's see what this is talking about. I can list out this series. I can start with k equals 1, and I'll have negative 2 over 1 to the 5th. When k equals 2, I'll have positive 2 over 2 to the 5th. K equals 3, negative 3 over 3, negative 2 over 3 to the 5th, positive 2 over 4 to the 5th, negative 2 over 5 to the 5th, positive 2 over 6 to the 5th, and so on, right? I can keep going on forever, and I can estimate this by chopping off my series and just adding the first couple terms. So if I added up the first two terms, I know that this first omitted term would be a bound on my error. If I added up the first three terms, I know that this first omitted term would be a bound on my error. So I need to figure out where I can chop this series off such that I have an absolute error less than 10 to the third. So I start by defining a sub k as 2 over k to the 5th, right? I'm ignoring the alternating part. So if that was the last term that I had in my estimate, then the k plus the a to the sub k plus 1 is going to tell me something about my error. So I have 2 over k plus 1 to the 5th, and I need that to be less than 1 over 1,000. So I can use some algebra here. I'll get 2,000 is less than k plus 1 to the 5th, and I can take the 5th root of both sides, and I'll end up with the 5th root of 2,000 minus 1 is less than k. So I used a calculator at this point. That's not something that I do in my head, and I get k is greater than 3.57, and the number keeps going, but I know my k is always an integer, so I'm going to set k equal to 4. So that means that that's where I'm going to cut off my series to estimate it. So I have the first 4 terms up to k equals 4 here is going to be my estimate. And then my error, I can tell something from this term. So if I put that into a calculator, that ends up being 0.00064, which is indeed less than my 10 to the negative 3. So my error here, the first neglected term, fits that criteria. So the problem asked me to estimate. So let's come back here and estimate. So what does that mean? That means I need to add up these terms. So once I add them up, again, this is a calculator thing, I get negative 1.9437 repeating. So depending on how we want to report this, I'm going to put this negative 1.944.